Thank you so much for joining us today. Just a quick show of hands. How many of you are starting with a brand new greenfield project? So about 3 of you, okay. That's good, because the rest of you should probably be raising your hands then that are on really old monoliths, but maybe adding new features or modifying existing features on top of that. Yeah, that's what I thought it would be. So we hope you walk away with an understanding of some of the symptoms you might be noticing that something's amiss as you're working on these huge monoliths. We'll take a brief glimpse at the ever-present testing triangle that feels like a myth, but what reality looks like, at least to us. How do people sometimes treat these symptoms, though? Some things seem like logical choices, but are not always considering the underlying problems. And by looking at what our test stack is doing, we can start to identify architectural patterns to really address the problems and learn to break down refactoring into an agile plan to make your app testable. I know I've seen this a few times yesterday. Angie and Anand did a great job highlighting this in their talks. This one just happens to highlight the importance and variance of lower level tests, which we'll talk about later. We've been talking about this for several years across various companies that I've worked at, and it's a work in progress right now for us. We're still working our way towards it, and I'm confident we'll get there. But in reality, we know it often ends up more like one of these. Raise your hand if these look familiar to you. Yep. So what do we actually tend to see in places trying to implement automation for tangled legacy systems? On the left, you see a case where you give up on automation and rely solely on manual tests, or you just haven't even tried yet. And particularly, in the bottom right one, we see a case where the project was started with the best intentions, but then schedule pressure set in. You kept getting feature requests, sales team started selling things that maybe weren't even ready yet. You probably noticed you had technical debt, but you were told you could address it after the next release. You end up with manual testing still being heavily relied upon with some automation in place. And sometimes you also see the amount of UI tests equaling the amount of manual testing because people find comfort in the UI. They automate because they can, not because they should. You still have a fairly large amount of manual testing going on, or you only do manual testing and skip the end altogether because people stop trusting them. And eventually, you get to this situation. Thousands of logged bugs due to regressions. It's impossible to triage. Feature development grinds to a halt because the app is large, unwieldy, and brittle, and you've hit gridlock. You may try to attack this by treating the symptoms. With so many bugs, and yes, that was a real bug queue with over 5,000 bugs in it, you might start poring over bug metrics and analysis, understanding root cause, identifying bug fixing sprints, and once you're in the thousands, you hit paralysis. Cost can be astronomical. Think about the cost of the developers you have looking at your bug queues. You have a lot of highly paid people reviewing this or getting assigned to bug fixing sprints. And this just introduces more churn in a brittle app because you have not addressed the underlying issues. It's hard to check in fixes that don't break something else in your app. So you might be inclined to hire more people. It sounds logical, but it can compound the problem. And if you're familiar with this book, Brooks likens it to putting gasoline on the fire. Even if more people were the answer, how productive are you in the first few weeks you've ever been hired? I think we've noticed around 3 to 6 months is the sweet spot for getting really productive with your new teams. And even transitioning teams and shifting people around that are already there requires a learning curve to understand how your new Scrum team works or how this other code base is looking. Some people may pull in temporary hires or contractors, but unfortunately, they also don't have a full picture when coming in. And sometimes you're just told to work harder. Kat and I have seen this almost everywhere we've worked. I've heard, oh, you'll get so much more job satisfaction if you just put in more hours and meet this deadline we promised our clients. And I get it. Sometimes long hours are just part of our job. But over a long period of time, and not as a repeated request, it can start to affect our lives and our stress sets in, and the morale just drops. You may also start hearing about new patterns. That may sound great in theory, but unless they can be practically applied, are useless. You might hear things like, oh, we need a more intensive code review process, or let's switch to mocking dependencies, or let's just put more comments in your code so we know what's going on. Over the years, I don't think I've seen many different treatments, but how do we break out of this cycle going nowhere? Actually, Kat and I want to introduce a new cycle, replacing the cycle of doom. And it may seem a bit heavy-handed, but after 10 years or 12, however long we've been doing this, it gets a little old. So there's 3 steps to achieving this. Identify your architectural issues through test result pattern analysis, categorizing, refactoring, and investigating. And finally, one of the cornerstones of agile development is iterative improvements. And we'll go through each of these steps in detail, using a real-world experience as an example. When we started, we had a legacy Java monolith with a new modern Angular front end and all of the ingredients for success. We had standard architectural patterns in place for componentization, MVC, dependency injection, and REST API. The project started small, and we used many of the standard patterns facilitated by Angular and REST-mod. Unit testing patterns were put in place, and an integration testing framework was custom written to support automated testing of common end-to-end workflows. Now we have almost 2-year-old front-end app that is essentially a legacy app now. Changes were and still are scary. Unit and automated tests became unreliable. There was little to no automated testing. Unit tests were bulky, and the build takes forever to run because of an underuse of dependency mocking in componentization or composition. Manual testing is still relied upon heavily, and regressions are running rampant.
Hi, is this working? Yeah. So I'm going to talk about how we as developers and architects can actually start to investigate the architectural underlying issues that might be the cause of what we're seeing in the app. And so in this case, we decided to actually look at the patterns in our testing to give us a clue as to where our architectural issues could be. So I'm going to go through this. I used to work at Blackboard too, and so I was part of this effort there. So the first example we'll go over is this. This is what we had in reality. All of our unit and automation test suites were passing consistently. But manual testing revealed regressions constantly, and the actual usage of the app was a terrible experience, particularly in common used areas of the application. So in this case, we can tell that our test results are not consistent with the actual working application, which means we have a lot of holes in our test coverage. And this is either because our developers aren't writing them or because there's not good enough componentization in the app to be able to actually write tests around these components, which means we have major holes in our coverage. And so we'll call this one poor componentization. So the second one we went through, we have this, again, giant suite of automated tests. They're running end-to-end tests on the whole application, and they're passing, but the app performance is extremely poor. So in this case, we know that our tests do not consider performance thresholds, or that testing is only done at the unit level where performance isn't an impact at all. And so for the underlying architectural issues here, we decided that we had to look at how the app was actually built. So underneath the application these days, we have they're implemented with these JavaScript frameworks that make it really easy for non-traditional JavaScript and front-end developers to create an application that work while they're working with classes and models and patterns that they are familiar with. They can ignore a lot of the web client specific practices like DOM manipulation, request traffic and size, minimization of the memory footprint, and things like that. And so these issues that are very common in web applications don't necessarily show up in our traditional testing practices. So we're going to call this one framework-induced bloat. And our next one, we see here, probably some of you are familiar with this type of graph from Jenkins. So this is a graph from our automated testing. And I don't know if you can see it really clearly here, but the top ones are green. Those are the ones passing. The yellow ones, which are getting larger and larger, are the tests that are being ignored because they're failing. And the bottom ones are failing. So here we see like a really inconsistent graph. These tests are completely unreliable. And so the issues here is that the test cases are either way too complicated to be running within the browser, so they're not stable, or you've got too much complex business logic that's in your application that you're trying to cover with end-to-end tests, where it should be much more ideally covered at the API layer. And so in this case, we had to test it at the front end because all of that complex business logic was actually implemented in the client. So we're going to call this one client-side business logic. And this then might lead you to completely give up on automated tests and rely on manual testing. And this happens sometimes because you've jumped into automation and you're trying to create a really widespread solution without verifying the stability first. And usually this is, again, because of pressure from the org to schedule, delivery, et cetera. Do you want to say something here?
Oh, I know I've seen this several times across my career. The most recent was just more, we have this framework, it was great. But at the same time, we didn't have the team. Once you put it in place, people forget, oh yeah, I still need to maintain it, and it's test as code, and you still have to care for it. So they just kind of, once people stop caring and stop trusting them, they want to kill them and not run them at all.
Okay, and so we'll refer to this one as test quantity over quality. And this concept applies generally to the nature of development on the app when you're just hurrying the whole time. So from this list, we can start to get into the categories of refactoring. So if you have a large refactoring project like this, it's really easy to fall into what we call analysis paralysis. So now that we've identified some critical architectural problems, we want to break this down. And so this way we can provide structure around the work. We're not going to take a bite off more than we can chew, and we'll have a good plan moving forward. So for our first architectural issue, poor componentization. So if you look here, you'll see an Angular template. And some of you might be familiar with this. And what you're essentially seeing here is our component for a text editor. And it's actually the same component for three very different types of text editor. One is for plain text entry, one is for rich text editing, and one is for math equation editor. And so if you look up here, you can see this is three components built into one that is basically a giant switch statement. And then in addition to that, under each of the different components, you see a huge number of attributes that can be used to customize the way the component behaves. And so the underlying view implementation is the same way. It's really difficult to decipher what the intended use of this component is. So oftentimes when you're having component issues in your application, people will suggest creating a common component library. I'm not against common component libraries. However, in this case, it will not help solve the problem, because basically what you're doing there is taking the overly generic components that you do have and just moving the code to a different place. And on top of that, you'll have the overhead of version maintenance and when to upgrade, and potentially a different set of developers working on each, contributing a communication overhead. So in this case, we don't really care about where this actual component code lives. We just know that this is not a good solution. This is brittle code, and it contains too much logic. So developers, QA, they are all going to be confused about how this is supposed to work. So what happens when tests break against this? Developers go in, and they change the test so that it passes, because they can't remember what the original component was supposed to do. And so if you have a component like this, when your users are actually using the application, they will have the same experience. It will be different every place they're using it. So the second issue we're discussing is called framework-induced bloat. So here in this image, you'll see a Chrome network tab. And basically, when we drilled down into this to look at our performance issues, we notice that we're making requests to pull down the same amount of data, the same exact data over and over again. And in addition to that, we're also pulling much more data than we need in many cases. So to this point, I'd like to mention again that many of these great libraries that we've gotten used to abstract the communication layer of the browser. And so we can rely, for the web, we can rely on the luxury of memory and bandwidth of our infrastructure in our browsers. And again, we work with classes and models, and we kind of ignore requests and payloads. And so in order to address this, there's a couple different things we could investigate. The first one is our REST API. Are we using it properly? Are we tailoring our requests so they pull down only the data that we need? This is the good thing that front-end frameworks do, is they allow you to easily tailor that. But you have to remember to do it. Another area that could be contributing here is in data caching. So if we have poor data caching client side, you're making a lot of requests for the same data because we have decoupled components done by different teams who haven't communicated with each other. And so when you translate this to the mobile platform, I mean, it's a disaster. Your battery life dies, and your performance is terrible. So for this one, we're called client-side business logic. So here you're taking a look at a unit test case. And this is the unit test for how to create a discussion board. So if you look here, this is a giant amount of weird logic that we want to use just when a user pushes a button to create a discussion board. And so I firmly believe that the bulk of client-side code should be around how to display the data being retrieved from the API and help the user interact with it. If your client has a lot of specialized business logic in it, you're going to need every front-end developer. Many front-end developers have a lot of experience with making things look and react really great. They may not have a lot of experience with the specific giant monolith that you are working on in your application and trying to jam a new front-end onto. So everybody who needs to start working on this is going to have to acquire all of this in-depth knowledge about the implementation of the entire system. And you'll also waste a lot of time in keeping multiple clients keep working the same way. If you have a third-party API, you can't tell people that this is what you need to do if you want to create a discussion board. And so then, in addition to this, you do not have a reliable place to write tests. Because the business logic is in the front end. It's not abstracted from the visual layer. And our front-end unit testing frameworks don't lend themselves well to this type of orchestration. So if your client-side tests are looking like this, it's time to look at restructuring your API. So for test quantity over quality, there isn't actually anything concrete here on its own. So as you'll see, we'll try to flip this ideology by addressing the quality of test coverage in our plan for refactoring, which leads to the Agile plan.
Thanks, Kat. So getting to your Agile plan is actually really tough without buy-in, or organizational buy-in, I should say. But your organization usually wants to know when will it be done, which leads to our favorite term, waterfall planning. Attempting to address all refactoring in one bulk effort with perfectly estimated time and resource management is usually what they're looking for. And has anybody ever had to do this? Does it work? No, that's what I thought. What we usually just hear is, oh, I just need a ballpark estimate. And so you think, I guess I can give them an arbitrary number, just my best guess, thinking, oh, it's okay. But someone somewhere remembers that ballpark, and it becomes the promised target date. If at all possible, it's best to find an executive sponsor who believes in Agile and who will support you, or at least a really good product owner who will understand the benefits versus risks of the situation. If you can't, you might want to just do it anyways, because it's iterative. It can be wrapped into most feature development. You need to resist the urge to create a new branch that will hold all refactoring work and give yourself a 3-month window to fix everything, because it will fail. So first, we're going to choose and isolate an area of the app. You want to do this as opposed to a breadth-first approach. This will allow you to demonstrate how all levels of refactoring contribute to the well-being of your app. And you'll end up with a clean example for moving on to the rest of the app. You can start with a simple one if you need to move quickly, or you can choose to start with the most complex one and aim to address all categories of performance. This area should exhibit at least 2 of the categories Kat discussed earlier that you're trying to address, but it may mean duplication of code for a short term. Test suites and builds should be isolated along with the app code to model ideal patterns there as well. And in the extreme, an entirely new physical app can be created to house the refactored code. And this should tie into your decision on how you move forward because your users would see a refresh in this case. Once you've picked the area you want to work on, it's time to get the team. Choose a small elite team and include QA on this. It might seem like a no-brainer, but unfortunately, it's not the case everywhere. And I can't say how many times I've seen efforts start, and then I ask, did you include testing in this? Only to hear crickets. You might need to assume manual testing or build in more reliable testing and use that. But for the rest of the app, remember, you want depth over breadth. And don't decide to introduce something quickly until you have a long record of stability through testing and know that it can grow well. And now it's time to create milestones. A milestone should be a high-level plan for delivery of some chunk of work. Usually it's a feature, but you can also use this practice for refactoring. Identifying concrete acceptance criteria for the milestone will help you focus the work. It will make it appear less scary to product owners and Scrum teams and give you the ability to know when you are done. And when writing your acceptance criteria, it often helps to focus by asking some basic questions about what you are doing.
All right, so now we're going to give examples for how we wrote milestones for each one of these categories of refactoring that we discussed. So like Ashley said, we did this by really asking questions to try to put some bounds around the work that we're doing. And so for the first one, around the generic component refactoring, you just start out and say, what is this milestone about? Well, generic component refactoring. And so what do we want out of this milestone? What are we delivering? Our end goal here is to break that text editor component up into several more focused components. And in addition to creating the new components, we'll need to refactor the front end of the discussion board only to use this new component. So remember, we've taken a chunk of the app, a complete vertical slice of the application that we're going to keep everything, all of our refactoring initiatives inside of for now. So you might think, we're refactoring this component and it's used everywhere, let's just change everything. So in this case, we would be introducing instability. We want to verify that this component works in its new place before we move on. So now, of course, QA folks will be asking, how will this be tested? And honestly, the developers should be asking this as well. And so in this case, we want to get as specific as we can. So let's aim for 90% of unit test coverage. And so you'll see here we're starting to fill in unit shape our pyramid that we talked about earlier. So is there anything else with testing? Yes, we'll need to write some integration tests. Again, we want to get specific. We just want to start small with this so we're not biting off more than we can chew. So we'll cover this component and how it interacts with the app in at least 5 test cases. So will the UX change? So these are visual components, and we're talking about breaking this component up, making it more consistent throughout the application. So in this case, we have to get design or our UX team to approve this change and be on board with that consistency across the app. Do we have any other concerns that we're forgetting? Well, we remember that people weren't very happy with this component, and we know our app has performance issues in general, so we want to add a performance assessment in here as well. So now we've got our acceptance criteria written, and remember, these are really high level for the milestone. And now the team can start breaking this down and writing stories about it and getting estimates and moving forward. So this one was very straightforward because we know the details of the problem already. We took a quick look at the code. It was very obvious. So we write this up, and it's pretty concrete. But what if you have no idea how to quantify the work? So in this case, it's really good to create a plan for planning. So we want to break it down a plan so that we don't just go on for weeks and weeks just doing investigation. So let's start. What are we investigating? We know the performance of the discussion board. Again, we're sticking to that same vertical slice is poor, and we've seen in Chrome DevTools there are a ton of requests being made for that page. So we'll focus this milestone on the discussion board request analysis. So what's our goal here? Again, we asked to find these performance bottlenecks and figure out how to fix them. So what do you need before you can estimate? Well, we need the list of extraneous requests and the unnecessarily heavy requests so that we know how to move forward and create work for this fix. So what else might help? So what else can we fix that's contributing to the poor performance from data management? We discussed that caching is always a good option, but we don't know what that would take to add to that front end at this point. So we'll use this milestone to investigate possible solutions and determine a concrete plan for our next milestones. And so for this investigation, we also really want to make sure that we're figuring out how we're going to do testing and a delivery plan for this client-side data caching, since we've never tested it before. So now we've got a concrete plan to figure out our next milestone. It's really important that this type of milestone be time-boxed. And it's probably planned as a series of spikes. If you're unfamiliar with what a spike is, it's basically a special type of user story that you use for investigation that you time box, and you, again, figure out specific acceptance criteria for what you want out of that spike. Otherwise, developers, we will go on and on forever because we love it. So let's go through this last example. Again, we're sticking to that discussion board because we want to demonstrate how the full slice of the application is improved through our refactoring. So what are we investigating? We need to do an analysis of the business logic in the application and decide what needs to be moved into the API. This is a great place to pull in a mobile team if you have one. It seems like some companies are structured so that mobile and web application development are completely separate, which this is where to start bringing those together because they both inform your REST API. So what do we need to know to move forward? We need to communicate REST API requirements to that services team or the developers. And is there anything that we can plan now, trying to get a handle on as much information as we have? So assuming we can work out on the agreement for the REST API, we know we'll be removing and simplifying a lot of front-end code, so we can attempt to quantify and organize this work. How are we going to test this? So we can drive this by defining test cases that apply to the business logic only and not the front-end code, which is ideally for display and user interaction only. So now we're starting to pull together that middle level of the pyramid. And the rest of the pyramid. So we'll need to determine a robust end-to-end test coverage plan to cover only common workflows and performance. Instead of having the big fat end-to-end testing that's very brittle, we need to pull that in and move more of it to the lower levels of the triangle. And so now you'll see this is our final milestone. Again, it's kind of a plan for planning, and you will move on from there. Finally,
thanks. It's time to apply this. The healthy cycle of planning, execution, and release that we use commonly for feature development can be leveraged for large refactoring projects as well. Keep your work contained and consistently releasable, and you will not bite off more than you can chew. Remember that the outcome of some milestones can be definition around the next milestones, as Kat illustrated. Show examples of why this is important and how it can help. And by doing a small slice, you can have your proof in the pudding and then be able to proliferate it across your other areas of your app. Don't tackle too much at one time. Don't try to do this for every feature at the same time, and just start small. Ensure that QA is involved in these discussions and engage all team members. You'll often find you need to also start training developers to start thinking like testers, because at least where I am, you have one tester on a team to sometimes 5 to 10 developers. We can't keep up, and we need them to learn from us as well in QA. And as Kat walked through, You can see how you go from maybe a T or square-shaped testing model to what seems so elusive but is now achievable. Thank you. Are there any questions?
So any questions? Or similar experiences? Where's the laser pointer? Yes, you.
Hey,
Thank
you. Do you have any advice for what to do in a scenario where you kind of have your sprint all kind of planned out and you have a nice plan for how you're going to start refactoring, and then management come in with a new feature they want you to implement, but they want it done last week, so of course you have to drop everything and then start on that, and then it completely disrupts your flow. And how do you kind of pick up again, or say to them, no, we're not going to do that now, we're going to do it next sprint?
Yeah, well, it helps if you have a really good Scrum Master product owner, but really the only way that you can get through something like that is to really make it obvious what the trade-offs are, right? And so you need to say, this is what you're losing. You could wait a week and we would have this, and this done because you've spelled it out really well in your plan. Or you can say, sure, we can get that feature development in, but the performance is still going to suffer. You're redirecting the team. You're losing time there. And you're just pushing off the problem. And then you can say, we will continue to suffer from regressions. That's all you can do is make that case over and over. Or just do it anyway and hope that it works out.
Thank you.
Anyone else?
Any more questions?
Right there.
Busy.
Sorry.
Hi. I was wondering how long the initial slice it, experiment took, and how long it took after that before you were at a stage where you felt happy.
Sure. So the initial phase, because we were able to keep it really tight, like those milestones that I talked about, they ended up taking just a couple sprints because we kept it so narrow. So within a month, we had a really good plan for planning type of situation, and we had made some good progress around the refactoring of the generic component. And so at that point, we had the good full-size plan to move forward, and then I left the company to go on a new opportunity. So you can probably speak more to what's happened now.
Yeah, so now what we've done is we now have a go-forward plan. We're going to start with small, more stable areas of the app, honestly. And we want to show that by applying these techniques, at least to the small areas first, get our traction going with that, which we're still working on. Learn from those mistakes that we've made, because everything in Agile is iterative. You're always going to have, your retrospective. What did we learn? What can we do better? And before we move on to the really meatier parts, then we'll move on after we've been able to iterate and apply what we've learned. So it's always an ongoing process. It never really ends. From my mind, nothing's ever perfect as a traditional tester. I can always find flaw with something. But yeah, so we're still learning, we're still applying. I think now we've finally learned how to plan for this and how to shore up testing to support this milestone plan to refactor. And then moving forward, we're always going to use that cycle to go on.
We saw great success as a whole using the milestone planning initiatives because, even for feature development, especially for feature development, actually, because we got out of this cycle where you'd get to the end of a few months of work and have all of the things we wanted to do 60% done. And so instead, with the rolling planning and delivery, you're able to get 100% done of 20% of the things, 100% done of 30% of the things. So at least at the end of any type of business cycle, you have something that's relatively good quality to deliver instead of just having to push off.
Yeah.
Hi, Ali here. Do you do load testing and stress testing at the company? And if you do, can you manage to fit in a Scrum, or how do you do it?
We're working on that, at least where I'm at. Kat's since moved on, so we're still in the process of really establishing good performance practices. And so that to us is still a lesson learned from how we had rolled out initially. So we still have, we've released our product, but we still need to look back at how we're doing performance testing, and not just at the front end, but at the back end as well. So we're still doing a lot of evaluation there.
Well, I think that's all the time we've got right now.
I think Ashley had
I have
one
one
more
more
thing.
thing. Happy birthday to my daughter. She is watching. So she is also listening, and I was hoping you guys would be so kind as to sing to her for her birthday.
Ready?
Happy birthday to you. Happy birthday to you. Happy birthday, dear Layla. Happy birthday to you. Thank you.
All right, we're going to take a 30-minute break. Be back at 5 minutes till 4 for the Selenium Committers panel.